Welcome to This Explainer. Okay, right off the bat, I want you to do me a favor. Forget the endless worksheets, forget the rote memorization of formulas, and absolutely forget that classic problem about when two trains leaving different stations will finally meet. Today, we're completely reframing how we look at all of this. We are going to look at mathematics not as some tedious chore, but as, arguably, humanity's greatest invention. We'll be tracing its incredible journey from a basic, everyday survival tool into what it is today, the literal source code of the physical universe.
All right, let's dive right into this with a mysterious, ancient doctrine from a philosophical group known as the Pythagoreans. Their core belief was beautifully simple, yet incredibly profound. All is number. Operating way back around the 6th century BC, the Pythagoreans were among the very first to look around at the absolute chaos of the natural world and suspect that underlying all of it was a hidden, rational order driven by math. And you know, this ancient quote is going to act as our guiding thesis today as we explore how this bold claim actually turned out to be completely true.
But hey, before we get to the deep secrets of the cosmos, we need to ask a really fundamental question. Is mathematics just a classroom subject? Because let's be honest, we naturally associate math with textbooks, formal schooling, and very rigid academic rigor. Well, let's bust that myth right now. The origins of mathematical thought are far, far older than the establishment of any formal school. Ancient civilizations didn't invent math to pass a midterm exam. They invented it because they absolutely had to.
Section 1. Origins Beyond the Classroom. So we're starting our journey in the mud, the dust, and the bustling markets of ancient history, where math was strictly a tool for survival and societal organization. In cradles of civilization, places like Mesopotamia and Egypt, math was born out of pure, unavoidable necessity. I mean, think about it. If you're running a growing society, you have to trade. You need to tax your citizens to fund the government. You've got to divide land accurately, especially when rivers flood and literally wash away property lines. And if you're in Egypt, you're using advanced geometry to engineer massive, monumental architecture, like the pyramids, aligning them to true north with stunning accuracy using nothing but shadows and right angles. They even needed math to track lunar and solar calendars to know exactly when to plant their crops. This wasn't abstract theory, this was the very infrastructure of ancient life.
Take Mesopotamia, for example. Dating back to around 3000 BCE, it's often considered the cradle of written mathematics. The Sumerians and Babylonians weren't just counting on their fingers. They utilized a highly complex sexagesimal, or base 60 number system. They were doing complex division, multiplication, and even tracking astronomical movements long before anything resembling modern schools existed. And by the way, if you've ever wondered why we have 60 seconds in a minute or 360 degrees in a circle, yep, you have these ancient accountants to thank for that.
And this timeline perfectly illustrates just how deep in the antiquity this goes. You have the Plimpton 322 clay tablet from the Babylonians dating back to roughly 2000 to 1900 BC. Then you have the Egyptian Moscow and Rhind mathematical papyri from the 1800s BC. What's just incredible to me is that these ancient texts already mention concepts like Pythagorean triples. Math was a physical, tangible record etched into clay and papyrus, solving the very real, everyday problems of the ancient world.
Section 2. The Pioneers of Abstraction.
Okay, let's fast forward and see how this builds from dirt-level land surveying right into the realm of formal abstract logic. We see this incredible leap forward driven by two legendary pioneers. First, you have the Greek mathematician Diophantus, often called the father of algebra. Operating in the Silver Age of Greek mathematics, he wrote a famous text called Arithmetica and introduced symbolic representation. He actually started using symbols for unknowns instead of just writing out numbers. Then, on the other side, during the 9th century Islamic Golden Age, we have the Persian mathematician Al-Khwarizmi. Now, where Diophantus was highly symbolic, Al-Khwarizmi was the absolute master of systematic procedure. He created a comprehensive, exhaustive approach to solving linear and quadratic equations.
In fact, Al-Khwarizmi's work is so foundational, it gave us the exact vocabulary we use today. He described fundamental methods of balancing equations, specifically referring to moving subtracted terms over to the other side of an equation to balance the whole thing out. He called this operation al-Jabr, which translated to restoration or completion. And as you can probably guess, that directly gave us the modern word algebra. He established this not just to solve a specific trade problem, but as an elementary mathematical discipline to be studied entirely for its own sake.
He provided this exhaustive explanation for solving quadratic equations, tackling the classic ax squared plus bx plus c equals 0 form in a generic, universal manner. By tackling equations universally like this, Al-Khwarizmi pushed math far beyond practical trade calculations and firmly into abstract theory. Math was no longer just about counting sheep or calculating taxes, right? It was now about defining infinite classes of problems and discovering universal truths. A real game changer.
Section 3. The language of physics.
And that level of abstraction brings us to a massive philosophical pivot in our explainer. We've moved from ancient markets to the abstract minds of algebraic pioneers, and now we enter a realm where human-invented numbers come to literally govern the laws of nature. The legendary astronomer and physicist Galileo Galilei famously recognized this exact phenomenon. He stated, "The book of nature is written in the language of mathematics." This represents a profound shift in human understanding. We transition from seeing math as just some historical tool for human bookkeeping to realizing that it is the very language of the universe itself. Simply put, if you want to understand physical reality, you have to speak its language.
I mean, take Newton's second law of motion. Force equals mass times acceleration. F equals ma. 3 simple letters that flawlessly model the physical world. They perfectly dictate how objects move, how physical force operates, and how momentum is transferred. It doesn't matter if it's a falling apple or a planetary orbit, the math just works.
Now, zooming out to the ultimate cosmic scale, the math scales right along with us. Through Einstein's general theory of relativity field equations, utilizing these incredibly complex tensors and non-Euclidean geometry, he was able to perfectly map the mind-bending realities of space, time, and gravity. The abstract math didn't just describe the universe we could see, it generated frameworks that predicted the existence of things like black holes decades before we could actually observe them. No way, right?
And if we zoom all the way down to the subatomic scale, we find the Schrödinger equation. Now, at this quantum level, reality gets really bizarre, yet entirely abstract human concepts, like linear operators acting in infinite dimensional spaces, perfectly predict the strange, probabilistic behavior of particles. Concepts developed purely in the minds of mathematicians turned out to be the exact operating instructions for electrons and photons.
So I'll leave you with this final beautiful thought from physicist Eugene Wigner, who wrote a famous paper on the unreasonable effectiveness of mathematics in the natural sciences. He called the appropriateness of the language of mathematics for formulating the laws of physics a wonderful gift which we neither understand nor deserve. It really leaves us with a deeply provocative question. If math is simply a tool invented by early humans to measure fields and track commerce, why is it so unreasonably effective at explaining the absolute deepest, most fundamental mysteries of the cosmos? Thank you for joining me on this explainer, and I hope this leaves you inspired to look at the hidden mathematical code of our universe in a whole new light.